Hello everyone, myself Dr. Ranjith Kumar Gatla, working as an associate professor in the Department of Electrical and Electronics Engineering. So today we are going to discuss about Z and Y parameters, and we will also see some numerical problems. So how to find Z and Y parameters for the given two-port network. So in the previous class we have already discussed the basics of the various two-port network parameters Z, Y, ABCD and H parameters. So in detail we are going to discuss about Z and Y parameters in this today's class. So as we discussed in the previous class, we know that the Z parameters are also called as the impedance parameters because in the purpose of these Z parameters are commonly used in the synthesis of the filters, and we have also discussed in the previous class like what are the various applications of these two-port network parameters, and which kind of networks that we can convert into the two-port networks. And here one of the application is filters. So especially these impedance parameters are commonly used in the synthesis of the filters, and of course they are also useful in the designing and analysis of the impedance matching networks in the power distribution network, because especially this is very important in the power distribution network, that impedance matching with the the supply and the load. So in those applications also it is very important, or in those applications also it is useful, these impedance parameters. And of course these Z parameters are also called as a the open circuit parameters, because here uh, we are going to find the Z parameters by considering the open circuit. Because here, as you can see, there are two ports. One is input port, another one is output port. And input side, two parameters are there: the voltage V1 and current I1. Similarly, the output side also voltage V1 and voltage V2 and current I2 is there. So here, uh, as you can see, of course, this we can find either by considering the open circuit or the short circuit. Okay, so here, but usually these Z parameters are also called as a open circuit parameters, because by making one terminal is open, so we will find the various parameters. The parameters, the Z parameters refer to the primary side, which means the input side, something like that. So if you write of course the Z parameters, especially the Z parameters, okay, we can represent the voltage as a function of the currents. The input and output voltage are the functions of the input and output current. So here the input and output voltages are V1, V2 are the functions of the input and output current, which are I1 and I2. So that's why here, and in another words, here the currents are the independent variables and the voltages are the dependent variables here, because here V1 is depends on I1 and I2 value, and similarly V2 is also depends on the value of I1 and I2. So that's why here V1, V2 are the independent variables, and dependent variables, and I1, I2 are the independent variables. Okay, so here, yeah, that's what here the two of four quantities are independent. Okay, so which means if we know I1 and I2, then we can easily find V1 and V2. So like that, that's why here the two parameters are the independent and the other two parameters are the dependent variables. So if you write the equations of V1 and V2, so here the equation for the V1 is in terms of I1 and I2 is Z11 I1 plus Z12 into I2, and similarly V2 is equal to Z21 I1 plus Z22 I2, right? So, and if you write these equations into the matrix form, then here the V1 V2 is equal to Z11 Z12 and Z21 Z22 into I1 I2. So, or in another words, simply the Z11 Z12 and Z21 Z22 can be replaced as a Z. So this is called as a impedance matrix. This matrix is called as impedance matrix, and this is the single column voltage matrix, and this is the single column current matrix. So in another words, here we can simply write V is equal to, okay, Z into I. So which means here V is equal to, here it is V1 V2, which is one column matrix, and Z equal to the Z is equal to here Z11, Z12 and Z22, sorry, Z21 and Z22. So this is 2 by 2 impedance matrix, and I is equal to I1, I2. This is again the single column matrix, right? So simply we can write it as a V is equal to Z into I. Then how to find the values of here the impedance parameters, which are Z11, Z12 and Z21 and Z22. As you can see here, first to find the values of Z11 and Z12, okay, so Z11, I'm sorry, Z11 and Z21, Z11 and Z21. So here we are considering the output side, or the port 2 is the open circuit. So by making the port 2 is open circuit, so which is nothing but we are making the current I2 is equal to 0. So then here Z11, which is equal to V1 by I1. So when I2 is equal to 0, which means the secondary side, that the second port is open circuit. And this Z11, that's why here Z11 is also called as a open circuit impedance. Open circuit input impedance, because here V1, I1 refers to both are the input side parameters. So that's why V1 by I1 is the impedance. And at what condition we are calculating the Z11 by making the output as an open circuit. So that's why here that open circuit input impedance, right? And similarly here the Z21 or Z12, okay, Z12 can be calculated as V1 by I2, again by making I1 is equal to 0, because already here in the denominator I2 is there. So if you make it I2 is again 0, then it will become infinite. So that's why Z12, that is open circuit transfer impedance from port 1 to port 2. Okay, so one is the input impedance, another one is the output impedance, and the other one is the transfer impedance. Okay, the open circuit transfer impedance, either it is port 1 to port 2, and another transfer impedance is port 2 to port 1. So when you are I mean make it input as a open circuit, then you will get the open circuit transfer impedance from port 1 to port 2. And when you are making the output as a open circuit, then you can find the Z21, which is also an open circuit transfer impedance from port 2 to port 1, right? Then here the Z22 is equal to open circuit output impedance. Okay, the Z22 that we can get by again making the input as a open circuit. So by that way we can find these Z parameters, which are the impedance parameters Z11, Z12, Z21, Z22. So because of this reason, because by making one terminal, okay, either input or output terminal is open, getting open circuit, so we are calculating the other two parameters of these impedance. So that's why these parameters are also called as a impedance parameters. Then here if you can draw the equivalent circuit for these open circuit parameters are the impedance parameters, as you can see here, because here this is Z11, which is referred to the input side, and Z22, which is referred to the output side. But here Z12 and Z21, okay, so which are the transfer what is that impedance from port 1 to 2 and 2 to 1. So that's why here we can draw the equivalent circuit is something like this. But when the two-port network is linear and has no dependent sources, okay, then the transfer impedance are equal, which means here the Z12, which is equal to Z21, and the two-port is said to be reciprocal. So when the two-port is said to be reciprocal, when the transfer impedance, okay, from port 1 to port 2 and port 2 to port 1 is same, then we can say that particular two-port network is a reciprocal. So in case of reciprocal network, okay, so we can what is that redraw or the replace the actual equivalent circuit into like this, because here the Z12 and Z21 is replaced something like this, because here Z12 is equal to Z21. So that's why instead of that here simply we can make it as a T equivalent circuit, which is shown in this figure. So this is all about the Z parameters. Then coming to the Y parameters. So here the Y parameters are also called as a admittance parameters, right? And these are also called as short circuit parameters. Short circuit parameters. Why? Because same like in the previous case, okay, so here also we are making one terminal as a short circuit at a time, I mean short circuit to find the other two parameters. And here the difference is before there the voltages are the dependent variables, but here the currents are the dependent variables, which means here the currents, the input and output currents I1, I2 are the functions of the input and output voltage. So that's why here the equation is I1 is equal to Y11 into V1 plus Y12 into V2. Similarly, here I2 is equal to Y21 into V1 plus Y22 into V2. So this is the way we can write the equations for the admittance parameters. And so of course, I mean, we can write these admittance parameters into the matrix form. So here I1 I2 is equal to y11 y12 and y21 y22 into v1 v2. So here I1 I2, this matrix is called as a current matrix, and this is called as a admittance matrix, and this is called as a the voltage matrix, right? So here, how we can find the parameters of these the y parameters, which are y11, y12, and y21, y22. Here, the values of the parameters can be determined by setting v1 is equal to 0, which means once input is get short circuited, or v2 is equal to 0, which means output should be get short circuited. So by making the input and output are short circuited, okay, so then we can find the values of y11 and y12, y21, and y22, the admittance matrix, the parameters of the admittance matrix. Then here, the same way as you can see here, initially, I mean, we have short circuited the secondary terminal, which is the output terminals. Okay, so that's why here the voltage across the short circuit is 0. So V2 is getting 0. And after that, I mean, by getting V2 is equal to 0, we can calculate Y11 and Y21. Okay, so because Y11 and Y21, of course, here admittance is the reciprocal of the impedance. So that's why here, before the admittance, I mean, the impedance Z11 is equal to V1 by I1. So here admittance Y11 is equal to I1 by V1. Similarly, Y21 is equal to I2 by V2. So again, here also, the Y11, which is the two parameters are the input side, refer to the input side. So that's why here the Y11, I mean, how we calculated Y11 by short circuiting the secondary terminal. So that's why here the Y11 is called as short circuit impedance admittance. Short circuit input admittance. Then similarly here Y21 is equal to I2 by V1. So here it is the transfer admittance. I mean, how we are calculating the transfer admittance? Again, by making the V2 is equal to 0, which means the secondary side is the short circuited. So that's why here Y21 is the transfer admittance from port 2 to port 1. So here 2 to 1. So that's why here it is Y21. And then again, by making V1 is equal to 0, which means the input terminal is getting short circuited, then we can calculate the Y12 and Y22 value. So Y12, which is equal to I1 by V2, and Y22, which is equal to I2 by V2. So here by substituting these values, then you can find Y12 and Y22. So again here Y12, because here the one I1 is the input side and I2 is the output side. So that's why here the Y12 is the short circuit transfer admittance from port 1 to port 2. Then similarly here Y22, which is equal to V2, I2 by V2. So here I2 is referred to the secondary side parameter and V2 is referred to the secondary side parameter. So that's why these are referred to the output side parameters. So that's why this Y22 is called as a short circuit output admittance. So by using these equations, so we can find the the various admittance parameters, which are Y11, Y12, Y21, and Y22. Right. So here one important point is the impedance and admittance parameters are collectively referred as a immitance parameters. So I mean, of course, there are various two-port network parameters. Okay, and two among those two-port network parameters are Y parameters and Z parameters. And these Y and Z parameters that we can also call it as are combinedly are collectively referred to as immitance parameters. So these two parameters are also called as a immitance parameters, which means what are the immitance parameters? Means the immitance parameters are the impedance parameters and the admittance parameters. So now let us just summarize the Z parameters and Y parameters. So as we know here, the Z parameters are the voltage equations in terms of as a functions of the currents. So which means here the currents are independent variables and the voltages are dependent variables. Okay, so that from that we can write the equations of the input voltage and output voltage. So that V1 is equal to Z11 I1 plus Z12 I2, and similarly here V2 is equal to Z21 I1 plus Z22 I2. And if you can go for the Y parameters, so here Y parameters are I1 is equal to functions of V1 and V2, which means here V1 and V2 are the independent variables and I1 and I2 are the dependent variables. So that here we can write the current equations in terms of the voltage, which means here I1 is equal to Y11 V1 plus Y12 V2, and I2 is equal to Y21 V1 plus Y22 V2. Then if you write these equations, similarly the other parameters also that we can discuss later. Okay, then how to find the Z11, Z22 and Z12 and Z21? Then by using these equations we can find. So that's why here, I mean, how by making the open circuit, we can find the Z parameters, and by making the short circuit, we can find the Y parameters. So that's why here the Z parameters are also called as a open circuit parameters, and the Y parameters are also called as a short circuit parameters, right? So now we are going to solve some numerical problems. Okay. So here this is the given problem. So for this given problem, we need to find the Z parameters, okay, and as well as if we consider the 4 ohms is the load, then the input current, let us consider V1 is equal to 24 volts, then find what is the load current which is flowing through the 4 ohms, which means I2 that we need to find. So first let us find the open circuit parameters, which are the Z parameters. So here, as we know, the equations for the Z parameters, which means the voltage equations in terms of the current. So which means here V1 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2. And first let us consider only the input side, which means by making output as a open circuit. So which means if you make output as a open circuit, then here I2 is equal to 0. So by making output as a open circuit, then we need to find by making output as a open circuit, so what are the 2 parameters that we can find? So we can find the 2 parameters are here the Z11 and here the another parameter is Z21, right? So as we know already, what is Z11? Z11 is equal to V1 by I1, okay, and similarly here Z21 is equal to V2 by I1, right? So if you are able to find V1 and V2 in terms of I1, then it is easy to find Z11 and Z22. So according to this what is that, this diagram, yes, so according to this figure here, when I2 is equal to 0, so we can find here the Z11 and Z21. So here Z11, then how we can find Z11, which means first if you are able to find the value of, because Z11 is equal to V1 by I1, so if you are able to find V1 value in terms of I1, then it is easy to find Z11. So then if you want to find the V1 in terms of I1, as you can see here, just apply the KVL to the this left hand side, because here it is having only one mesh, okay, or one loop. So for this, then you can get here 12 into I1 plus 6 I1, which is equal to V1. Then here V1 is equal to 18 into I1, right? Then here Z11 is equal to V1 into I1. So V1 is equal to 18 into I1 by I1. So that here I1 gets cancelled, then 18. So here, which means here Z11 is equal to 18. So this is how we can find Z11. And similarly here, we need to find Z12, so that we need to find the voltage V2. Again, apply the KCL for this particular loop. So anyway, here I2 is equal to 0. So here you no need to consider the what is that, the resistor 3 ohms. Then here again, if you apply the KVL to the loop 2, so here you will get minus V2 plus here 3 into 0, because 3 into I2 is equal to 0, plus 6 into I1, which is equal to 0. So from here V2 is equal to 6 into I1. Then similarly here Z21 is equal to here V2 by what is that, I1. So here 6 into I1 by I1. So here I1 gets cancelled, then you will get Z21 is equal to 6 ohms. So this way you can find what is that the values of Z11 and Z21. Then similarly, by making the input what is that the secondary, I mean the input side as a open circuit, okay, so that here I1 is equal to 0, okay, then we need to find again V1 V2 in terms of I2, V1 V2 in terms of I2. So further here again, let me, I mean, what are the other two parameters that we can find by making what is that this thing is, one is Z22, another one is Z21, okay. So here Z22 which is equal to V2 by I2, right, and Z21 is equal to V2 by I1. So okay, so sorry, not Z21, Z12 actually, because before we have already calculated Z12, here it is. So Z12 is equal to V1 by I2, V1 by I2. So again here also we need to find the value of V2 in terms of I2 and the value of V1 in terms of I2, right? So further, first let me find here what is that the V1 value. So V1 again just to make open circuit. So here this will be open circuit. So here the 12, the current flowing through the 12 becomes 0. So here which means V1 is equal to 12 into 0 plus again here 6 into I1, the current flowing through this one is 6 into sorry, I1 is equal to 0, so 6 into I2, then here you will get, so V1 is equal to 6 I2, then substitute here, then Z 212 is equal to, here V1 is 6 I2 by I2, so I2 gets cancelled, here Z12 is equal to 6. Then similarly, if you apply to the another loop, if you apply another loop, then here minus V2 plus 3I2 plus 6I2 is equal to 0, right? Because here, if this is a loop, okay. Then here 3 plus 6, 9. So V2 is equal to 9I2. Then again here you can find Z22 which is equal to V2 is 9I2 by I2. So then you will get 9. Then finally here the impedance, I mean the impedance matrix before the values are this what is that and another. So now we have calculated all the two port network parameters which are Z11, Z12 and Z21 and Z22. So this is the way we can find the Z parameters in a network, right? The Z parameters in a given network, right? Then another one is, suppose if the current 4 amperes load and the input voltage V1 is equal to 24 volts, then what is the current flowing through this 4 ohms load resistor? So for that here, which means here, let us consider the load terminal which are connected to the output side, and the load, what is that resistance that they given in the problem is 4 ohms. And now find the current flowing through this I2, right? So here to find the current flowing through I2, just combine the equation 1 and 2. So the equation 1 and 2 which are referred to the what is that the V1, I mean the first loop, and 2 is the second loop, okay, by making the 1 is the short circuit. So here then you will get the V1 which is equal to 24. I mean the equation is, let me write again the equation here. So V1 is equal to 18I1 plus 6I2. Okay, 18I1 plus 6I2, because here this is Z11 is 18 and Z12 is 6. Okay. Then here, you know what is V1, just now they have given. So 24 at an angle of 0. So that's why I'm just neglecting. So 24 is equal to, okay, so 18I1 plus 6I2. 18I1 plus 6I2, right? So similarly, what is that? V2 is equal to 6 into I1 plus 13 into I2. 6 into I1 plus 13 into I2. So here V2, because that V2, okay. So let us make it as a I mean because in the first case we are making it. Then here 0 is equal to 6I1 plus 13I2. 6I1 plus 13I2. Then here we are having two equations. By solving these two equations, right? So we can find I1 and I2 values. Then by solving these two equations, you can find the value of I2, which is equal to minus 0.73, of course, at an angle of again the 0 degree. So this is how we can find the value of the I2. Next, we are going to discuss about the another problem, which is about the y parameters. Now, calculate the y parameters for the given circuit, okay, or for the given T circuit. So, as we know, I mean, y parameters are also called as a short circuit parameters. So, which means by making what is that the output, okay, as a short circuit, which means a short circuit is nothing but, let us consider V2. So by making V2 as 0, then we can find what are the two parameters that we can find, y11 and y21. Okay, y11 and sorry, not y21, y12. Yeah, y11 and y21 that we can find. Then by making V1 is equal to 0, the other two parameters, which are y12 and y22, that we can find. Okay, so first let us make it V2 is equal to 0. Okay, so let us make it V2 is equal to 0. So which means we are making the output terminal as a short circuit. So as we know here, the y11 which is equal to I1 by V1. So and another thing also, we know that the impedance parameters are nothing but the current equations in terms of voltage. So y11 into V1 plus y12 into V2. Okay, so the current equation in terms of the voltages, right? So now if you are able to find what is that the I1 value in terms of V1 or V1 value in terms of what is that I1, then it is easy, because anyway it is easy to find the values of y11 and y12, right? So for that, suppose in this circuit, let us find the total current V. Okay, so total current I or I1, because here this is the current, this is I1. So I1 is equal to V by then R total, right? So here we don't know V, but let us consider here V is equal to V1. Okay, that we are considered. So V1 by, so of course, as you can see, if you get short circuit this terminal, then here 2 ohms and 2 ohms are in the parallel, and the combination is in series with the 4. So that's why here I am just writing here 4 plus 2 into 2 by 2 plus 2, then which is nothing but V1 by 5. V1 by 5. Then substitute this I1 value in this equation. So y11, which is equal to here, I1 is V1 by 5. Okay, so by here again V1. So V1 gets cancelled, then you will get 1 by 5. Okay, so here y11 is equal to 1 by 5. Then similarly, we can find what is that y21. So y21, which is I2 by V1. So which means we need to find I2 value in terms of V1. Then how to find I2 value in terms of V1? Because as we know, here I1 is the total current in this circuit. Then you can easily find I2 in terms of I1, because here by using the current division rule. So by using the current division rule here, I2 is equal to, or because of course the direction is opposite, so that's why let us consider minus I2. Minus I2 is equal to I1 into, of course, the opposite resistor here, it is of course both are same. So that's why here we can simply write 2 by 2 plus 2. So which means here I1 by 2. Then I2 is equal to minus I1 by 2. So which means here I2 is equal to minus I1 by 2. Then substitute this value in what is that, y21. Yeah, y21 is equal to I2 by what is that, V1. So here I2 is minus I1 by I1 by, no, again just yeah, here we have calculated I2 value. Then after that here, because we need to find I2 in terms of V1, right? So we know that V1 is equal to, okay, so 5 into I1 because just now we have calculated v1 is equal to 5 into I1 from where, from this equation, because here it is called I1. So here v1 is equal to 5 into I1, then substitute here. Okay, then I2 is equal to what is that, the 5 into, okay, I1. So which means here you will get v1 is equal to what is that, 10 minus 10 into I2 minus 10 into I2. So which means here I2 is equal to minus 1 by 10, right? Then here y21 is equal to minus, not minus 1 by 10, minus v by 10, right? So then here minus v by 10, v1 minus v1 by 10 by v1. So v1 gets cancelled, then you will get here minus 1 by 10, which is y21. So now we got the value of y11 and then y21. Then now we are going to find the another two parameters. So for that we are making the input side as a, and further we are making the input side as a short circuit. So which means here we are making v1 is equal to 0. Again the same way that we have find here, what are the other two parameters that we can find here? It is y22, right? y22 and y12, y22 and y12. These are the two parameters that we can find. So here y22 is equal to, again y22, what is y22 here? v2 by no, not v2, I2 by v2. y22 is equal to I2 by v2, and similarly y12 is equal to I1 by v2. Right. So now here we need to find I1 and I2 values in terms of V2. Okay. The same way here. Okay. Then again first find I2. So I2 is equal to V2 by, now here 2 and 4 are in parallel, and the parallel combination is series with the 2. So that's why 2 plus 4 into 2 by 4 plus 2. Then the value of I2 here it is 3V2 by 10. Okay. 3V2 by 10. Then here y22 is equal to I2. Here I2 is 3V2 by 10. Let me write here directly. So 3V2 by 10 by V2. So here V2 gets cancelled. Then here 3 by 10. This is y22. Then similarly we can find the same way here again. Let us find the current I1. Okay. So because again opposite direction. So minus I1 is equal to the total current here, it is I2 into the opposite resistor is 2 by 2 plus 4. So here the minus I1 which is equal to I2 by 3. Then again apply the KVL to the loop 2. So if you apply the KVL to the loop 2, then V2 is equal to 4 into I2 plus 2 into I1. Then substitute this value, then you will get minus 10 I1. Okay, so that I1 is equal to here because I1 in terms of V2, I1 is equal to minus V2 by 10. Then here y12, so here y12 which is equal to I1 by V2, which is equal to I1 is minus V2 by 10 by 10. So then you will get minus 1 by 10. So this is y2. So this way we can find the value of the the various y parameters. So that's why here we can also call it as a short circuit parameters, because by making short circuit of one terminal, so we can find the other two parameters, right? So in the next class we will discuss the remaining two-port network parameters. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.